Okay, so the final challenge was to gradually deform a 720-degree rotation loop to the stationary loop. So I hope you managed this. And let's see one solution by Aditi. All right, so how did this solution relate to the other challenges? Um, did anything seem familiar that you did while you were deforming this 720-degree loop to the stationary loop? And did we end up using any of the other challenges in the process? Well, what are we actually doing? In some sense, this 720-degree loop is with respect to the y-axis, but it's two 360-degree loops concatenated with respect to the y-axis. And as we start creating this figure 8 movement, we're actually pulling those two loops apart, pulling the axes apart. And just like we saw earlier, any two 360-degree loops are equivalent, we're actually bringing the first 360-degree loop to a 360 about the x-axis, and the second one to a 360 about the opposite x-axis, which then allows us, so really it becomes two loops that cancel out from one another until eventually it just deforms to a wobble and then a stationary loop. So in some sense, we're putting all of these challenges together as part of this process of deforming the 720-degree loop to a stationary loop. Okay, so let's now give a big theorem about loops in orientation space. So it turns out that all the non-trivial loops are equivalent to each other. So we can deform any non-trivial loop, no matter how crazy, to a simple 360-degree rotation about any axis of your choice. So any two non-trivial loops are equivalent to each other, which means that there's really only two types of loops in the world. There's trivial and non-trivial. Every loop is either trivial or non-trivial, and all the non-trivial are equivalent. So up to equivalence, there's just two loops in orientation space. So the proof of this that I know of relies on algebraic topology and the idea of a covering space. But perhaps you can come up with something more direct, at least in some special cases. And in any case, it's a fun theorem to think about because intuitively, you might think there's some really crazy loops out there that are simply not equivalent to either a simple 360-degree loop or the stationary loop. But this theorem tells you that it has to be equivalent to one of those. So that's an interesting theorem about the nature of orientation space itself. Now, as a final challenge, can you smoothly deform other 720-degree rotation loops to the stationary loop? We did it with the 720-degree y rotation loop, but it's true for any 720-degree loop. You can always deform it to a stationary loop. So we've already seen, for example, how to do a 720-degree z rotation as a continuous movement. So maybe you could try and enact a gradual deformation of that loop to a stationary loop. Or maybe you could try and do a 720-degree x rotation. But for that, it'll be very helpful if you can perform a 720-degree x rotation as a continuous movement. So that's a fun game to play to see if you can do that. And if you'd like to try it yourself, stop the video now. But that's the last thing that we'll see in this video, is a way to perform a 720-degree x rotation as a continuous motion, which you could then use to enact the gradual deformation to the stationary loop. So stop the video now if you want to try it yourself. Otherwise, let's see Sharan's solution to this.